Hello class, so today we're going to be talking about solving proportion. So for number 1, the question is 1.5 over 6 is equal to 10 over p. So what we're going to be trying to do is solve for p. So what we want to do first is see how many times 10 goes into 1.5. So when you divide 10 divided by 1.5, you get 6.6 and repeating. So then once you do that, you're going to do 6.6 and multiply it by the number below 1.5. So you get 6. So 6 times 6, or 6.6 multiplied by 6 is equal to about 40. So how we did that is we went from 10 divided by 1.5, and then you take whatever answer that is and multiply it by the number below. So that is how we solve that problem. For number 2, we're going to do the same thing. So we start with the number that has the proportion underneath, or the one that we don't know underneath, which is the p, and we do 44 divided by 11, and you get 4. So we went from this number and divided it, and then now we are going to multiply this number by our answer, which is 4. So we do 5 times 4, that's supposed to be 4, equals 20. So p equals 20. And for number 3, we're going to do the same thing we've been doing. So you start with the number that has the one we don't know underneath, so 2 divided by 0.4 is equal to 5. And then, so we divided that, and now we have to multiply whatever answer we got, which is 5, multiply it by this 0.7. So 5 times 0.7 is equal to 3.5. So your answer is 3.5. Alright, now we're going to do number 4. And so for this one, we have to set up a proportional. So what we're going to do is put $1.12 on top over 12, because we know a dozen is 12. And what we want to know is determine the cost of 3 eggs. So we have eggs on the bottom, so we would put 3 on the bottom again because we're doing eggs on the bottom, and we want to know how much that would cost. So to figure this out, you start with the 12 and you figure out that, well, 12 divided by 4 equals 3, and that's our two numbers right here. So we have to divide $1.12 divided by 4, and we would get 0.28. So 3 eggs would be 28 cents. So how we did that was finding what this number is divided by this number. So then we had to do the same for this. So once we figured out what that number was, and it was 4, we divided this number by 4. Alright, for number 5, we're going to do kind of the same thing. So it says that there are 2 ounces of yellow paint, and what we want to know for the ending is how many ounces of yellow paint again. So we're going to put 2 on the top, and she said that there was 3 ounces of blue paint and 2 ounces of yellow paint. So what we're going to do is add those together, so we get 5, and that is equal to, she decides to make 20 ounces of the same mixture. So the 5 is the total that she made the first time, so we have to put the total on the bottom again. So she decided to make 20 ounces this time, so we put that on the bottom. And what we want to know is how many yellow paint, which is our top number, so we put that as an X. So how we figure this one out is we do 20, we start with the one with the proportion, or the X on top, and we start with 20, so we do 20 divided by 5, and we know that's 4. So if we had to divide this number by 4, then that means we have to divide this number by 4 to get 2. So to figure that out, we do 2 times 4, and we got this 2 from right here, and we get 8. So the answer is 8 ounces. For this problem, it says that a car travels 467 miles on 14 gallons. So that's our rate right there. So 476 over 14. And it says to write an equation relating the distance to the number of gallons. So we're going to figure out that, well, if it's 174 miles over 14 gallons, we want to figure out what 1 mile would be per gallon. So, or what 1 gallon would be per mile. So we divide that out and we get about 34 miles per 1 gallon. So our equation for that could be D, which stands for distance, equals 34 gallons. And that would be our equation. But then the next question is, how many gallons of gas does the car need to travel? 578 miles. So we would do 578 divided by 34, because we know you get 34 miles per gallon. So when you divide that out, then you get 17 gallons, and that would be your other answer. So this question is kind of the same thing. So we know that for $2.50, you can get 5 pounds of bananas. So when you divide that out, you get 0.5 or 50 cents. So the question is how much, or write an equation. So if we know that the cost is equal to 0.5, so 50 cents. So cost is 50 cents per pound of bananas. And then it says how much would Miss Baker pay for 8 pounds of bananas? So if we know that per 1 pound it's 50 cents, and we want to know 8 pounds, we just multiply 0.5 times 8, and you would get $4 for your answer. So for number 8, this is still kind of the same kind of problem. So there we have a woman who is 64 inches tall and has a shoulder width of 16 inches. So that's going to be our proportion. So 64 inches over 16 inches. And you want to find an equation for the height compared to the width. So this top one is the height and the bottom is the width. So if we divide that out, we get 4. So we know that height is equal to 4 width if you divide 64 by 16. So the second part of the question is asking, find the height of a woman who has a shoulder width of 18.5 inches. So if we put that into our equation, height is equal to 4, and then width, we know, is 18.5 inches. So we multiply 18.5 times 4, and then we get that equals 74 inches, and that is your answer. Alright, so we're going to be solving proportions here. So just like on the other page, we're going to do kind of the same thing but a little bit different. So on the other page we had the variable on the bottom, but now it's on the top. So we're still going to start with the same way we did before. So we're going to start with the number that is below the variable. So we do 30 divided by 25. So we're taking the two bottom numbers, and then we divide them out, and that is equal to 1.2. And then So you divide these two numbers, and then you multiply that answer by 6. So our answer was 1.2, so you do 1.2 times 6, and that equals 7.2. So our answer for what is D is 7.2. So we're going to do the same thing here. We start with the number that has the variable on top. So we do 9 divided by 6, and that equals 1.5. And then you multiply it by the other number that you didn't use yet. So 1.5 times 2.5, and that is equal to 3.75. So H is equal to 3.75. Alright, for number 21, we're figuring out how much Jeremiah saved after 8 weeks and the equation. So, it says that after 3 weeks he saved $135 dollars. So we're going to start with 135 over 3 so we can figure out what he made in 1 week. So we're dividing 135 by 3 and you get $45. So so to do the equation, it says S is saved, so how much money he saved, and then W is the number of weeks. So he saved $45 per week. So that would be your equation. And then it says, at this rate, how much would Jeremiah save after 8 weeks? So we could put that back into the equation. So how much did he save is what we want to know. And we know that he saves $45, and W is or how many weeks. And it was, as we looked in the problem, 8 weeks. So do 45 times 8. And what we get is $360. So that is how much that he saved after 8 weeks. Alright, so for this, the first problem is asking the constant rate of change for each table. So what we're going to do is try to find per one how much is it of the other. So what you would do would be find look at the first number, and in the left column it's 1, and on the right it says 6. So the distance is 6 meters per 1 second. In number 2, it's asking the same thing, but as you can see, the first one starts with 2 instead of 1. So we need to figure out what would be 1 before that. So if we have 1 on this column, we divide it by 2. So we have to divide the right column by 2 as well. So you do 18 divided by 2, and we know that that is equal to 9. So we know that the rate of change is equal to $9 per item. So for number 3, it says the graph shows the cost of purchasing t-shirts. So find the constant rate of change for the graph. So what we're going to do first is look at the graph, and if you look at it, it says that per 1 shirt, if you look up and you find the point, which is 1.9 that it says right here, per 1 shirt it costs $9. So that would be your rate of change. So it'd be $9 per shirt. You can write that down. And then next it says explain point 0, 0, and 1, 9 and what they represent. So if you look at the graph and you look at 0, 0 right here, that means that 0 number of shirts cost $0 because you haven't bought anything, so it would be 0. And then the next point is 1, 9. So if we just talked about that one, so if you look where your 1 is for number of shirts and you find the 9 over here, that's going to be 1 shirt is equal to $9. So in number 4, they're asking which family averaged fewer miles per hour. So if we look at this one over here, it says that they traveled 2 hours, or in 2 hours they traveled 90 minutes. But we know that we have to make that 1. So if we divide 2 by 1, we get 1, and then, or 2 by 2, we get 1. And then we also have to divide, since we divided this number by 2, we have to divide this number by 2. So then 90 divided by 2 is equal to 45. So we know that this family went 1 hour and they traveled 45 miles. And then if we look at the graph over here, if we look at how many hours they traveled, if you look at 1 and you look at the graph and you look at the line, it crosses right at 60. So we know that this family traveled 1 hour, or for 1 hour they traveled 60 miles. So the question is, which family averaged fewer miles per hour? So we figured out that this family traveled 45 and this family traveled 60. So the Guzman's family traveled fewer miles per hour. So for number 5, they're asking what is the rate of change for this problem. So what I did was kind of made a little table. So I did time and inches. So we know that at 1 p.m. the pool level was 13 inches. And then we know at 1:30 the water level was 18 inches. And then it says at 2:30 it was 28 inches. So we don't know this number right here. So for 1 or 2 o'clock, we don't know. But we can figure it out, because if we do 13 to 18, we figure out that that's a rate of change of 5. And from 18 to 28, we see that that's a rate change of 10. So to figure that out, to figure out what it would be at 2 o'clock, we just add 5 to 18, and you get 23. So the question is asking, what is the constant rate of change? So we figured out that per 1 hour, so if we look from 1 to 2, we are going from 13 to 23. So we know that we are going 10 inches per hour. So for number 11, they're trying to find the constant rate of change. So we know that when we look at the rates, we have to find one something per something else. So since this starts with 1,000, we want to make it equal to 1. So we're going to do 38 divided by 1,000. And then what we're going to get is 0.038. So we know that per 0.308 dollars, so 38 cents, it is going to be 1 minute is equal to 1 minute, so per minute. So for number 12, they're asking you find the constant rate of change. So if we look at our graph, we see that our first, besides 0, 0, our first point is 72. So to find our rate of change, what you do is you do 72 divided by 6, and what you get is 12. So we know that per 12 pages, or we print 12 pages per minute. Then it's asking what 0, 0 means, the point 0, 0. So if you look on our graph, 0, 0 means that 0 pages were printed in 0 minutes. And then the other point is 672, so that means that if you look here, here's our 6 in 6 minutes, 72 pages were printed. So for number 13, they're asking who charged more per hour. So in Ramona's, we see that in 2 hours, she charged $18, but we want to figure out what 1 hour would be. So we divide that by 2. So we have 1, and we divide that by, or 2, and we divide that by 2, and we get 1. And then we have to also divide 18 by 2, and we get 9. So we know that per 1 hour, she charged $9. And then in Josh's earnings, we see that per 1 hour, he charged $10. Because if you look on the graph and look at 1, and you go up, this is the dot right here, and if you go over, then it's 10. So we know that he charged $10 an hour. So the question is, who charged more? So we know that Josh charged more, if you look at the graph. So for number 14, they're asking, based on a rate of change, what is the cost of 4 movie tickets? So I made a table for this one again too. So I did tickets and how much it costs, so dollars. And so we know that 1 movie ticket costs $7.50 and 2 movie tickets cost $15. So what it wants to know is what is 4 movie tickets. So we know that 1 is equal to $7.50. So we just multiply $7.50 times 4. And then when you multiply that out, you get that it is equal to 30. So our answer would be $30 for 4 tickets.